Today we're going to be talking about graphing systems of inequalities and what's entailed with that. So here we have two inequalities in the form of y is less than or equal to 3x plus 2 and y is greater than negative x plus 4. So let's go ahead and we'll start off by graphing the lines. With the first one, y is greater than or equal to 3x plus 2, we're going to use we're going to use a solid line. And because that's going to show us that anything on that line is going to be a solution. So let's see, let's start off by plotting some points. So we start at plus 2. And then we go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. And let me get one more point, but in the other direction. So down 3, 1, 2, 3, and left. We'll connect our points. Make sure your lines extend the entirety of your graph. Okay. All right, now we're going to look at our line here, and we need to figure out what this inequality means and how we represent it. So this is simply stating that, in fact, values of y, or solutions, are values of y that are less than 3x plus 2. So that means any value of y that's less than this line represents 3x plus 2. And the y values, we want y values that are less than that. So we ask ourselves, which direction is y going to be less than compared to the line? Well, as we know, on the number line, the vertical part, y gets less than as you go down. So like we have -1, -2, -3, so forth. So that means we're going to shade everything below that line. And the reason that we used a solid line is that anything on that line is a solution. Because remember, we said that if you're solving equations, then solutions to an equation is going to be anything or any point on that line. You can take any point on the equation line, substitute it in, and you'll get a true statement. All right, so that's good enough. All right, now we're going to look at the next inequality. So y is greater than negative x plus 4. Now, notice, we're going to graph this just like the other one. Before I get ahead of myself, 1, 2, 3, 4. So there's our y-intercept, and we go down 1, over 1, down 1, over 1, and down 1, over 1. Okay, so notice that this one lacks the equal to part. It's just a greater than sign. So that means any solutions on the line or any point on the line is not a solution. So we must use a dashed line representing, there's a limit here, but does not include the line itself. All right, so we want to figure out, well, what side do we shade on this one? Well, since y is greater than negative x plus 4, So this line represents negative x plus 4. We ask ourselves for which values, or where does y get greater than? Which direction, up or down? That's how I want you to think of it. Do you shade above the line or below the line? So if y is less than, then you shade below. And if y is greater than, well, you shade above, because y gets greater the further up you go. So I would suggest that you use a different color when you shade this, or if you shaded one way here, you can shade like maybe using horizontal lines in the other one. You can use vertical, horizontal lines if you just only have a pencil or a single color pen. And so we're going to get everything above this line. So some of it's going to be outside of the shaded region for the first one. Some of it's going to be inside. But we want to get everything, because all of this stuff is, in fact, a solution. Now, you'll notice it's a different color where they overlap, because I'm using two different colors. And any point, basically, in this shaded region is a solution of both. So basically, if I were to pick a point, let's say like here, any point in this yellow region, here or here, is going to be a solution for the first equation or inequality. And anything in this blue region is going to be a solution for this one. So if I pick just this point here, then it will work. It'll get a true statement for the yellow one, but it won't work for the blue, for the second one. And if I pick a point up here, it will be a solution for the second inequality, but it will not work for the first. So your solution region to the system is any point in this green area. And we can test that by picking a point and seeing how that goes. So let's see, I want something easy to work with. So I'm going to pick this point right on the x-axis. So that's going to be 1, 2, 3, 4. So that's going to be 5, 0. And let's test this point. Let's see what happens. Okay, so for the first inequality, where we have y is less than or equal to 3x plus 2, I'm going to plug in 0 for y is less than or equal to 3 times 5 plus 2. And that's going to leave us with 0 is less than or equal to 15 plus 2 plus 2. And 0 is less than or equal to 17. Is that true? Is 0 less than or equal to 17? And our answer to that would be yes. Okay, so let's works for the first one, but what about the second one? So its 0 is greater than negative 5 plus 4. 0 is greater than negative 1. Is that true? Yes, it is. So we can see that this point here is a solution for this system of inequalities, as is any point in this overlapping region.